Hi everybody. As we work toward completing Chapter 2, we're now going to work on Chapter 2, Section 3. So it's essentially Section 2.3. And what we're going to talk about specifically is this section right here, calculating percentages. And we're essentially going to switch gears just a little bit. We just got done learning about relative errors, and we learned that they are typically expressed as percentages. So now we're going to talk about percentages in just a little bit more detail. As you'll see, they can be kind of confusing, and that's why it's important to talk about it, because sometimes they're often misused and thus confused by others. So let's go through a couple examples of things, but let's start off easy just by talking about some basic mathematical conversions. Because we're going to be dealing with percentages and converting things to percentages typically in our final answers, I just want to make sure you remember some of the basics that you've learned in other classes. So we'll just look at this real quickly. Now remember, at any point you can stop one of these videos. So, if you want to look at anything on this sheet in a little bit more detail, you could just hit pause. It's no problem. So to convert a percentage to a common fraction, just remember what it means when we say something like 25%. Percent essentially means per 100. So a fraction would show 25 hundredths, which could be reduced down to 1/4 or 1/4. To convert a percentage to a decimal, well, remember again, 25% is 25 hundredths. So when we look at that decimal point, to the right, one decimal place is the tenths, and to the right, the second decimal place is the 100ths place. So we have 25 hundredths. So again, it makes sense. As we move on down, to convert a decimal to a percentage, now we're just kind of working in reverse. So this is 43 hundredths, or 43%. And then, of course, to convert a fraction to a percentage, you would actually do the math first, and you typically use your calculator. So if we had 1/5, like we see right here, let me pull out my calculator. We would just take 1, divide by 5, so we'd get a decimal place of 0.2, and then we'd realize that that's 20 hundredths. It's 2/10ths, but you can just imagine it as 0.20. So let me just clear out the calculator. 0.20, 21 hundredths, or 20%. So it's really that easy. All right, that was just some of the basics, just to kind of get you thinking about percentages again. Let me just kind of introduce this topic by giving you a little example of a dubious or questionable product claim. And this is from Campbell's Soup. So Campbell's at one point advertised that their new soup had 25% less sodium. And as you probably know, soup is often characterized as being a very high salt type of food. So if your new product has 25% less sodium, that sounds good. But my question would be, 25 less of what? That's going to be a common theme today as we're talking about these percentages. We'll be using reference values and computing change scores and things like that. So when we talk about 25% of something or some type of change, we always have to ask, where did things begin? So what you would probably assume is that this new soup right here has 25% less sodium than the previous soup that they were selling. But that's not necessarily the case. And although it's tough to read this small print in here, what they're really talking about is 25% less than the average condensed soup on the market, not 25% less than their previous version. So it's possible, it's entirely possible, that there's actually no change at all from one product to the next. They're just doing a comparison between their product and other existing products. So that's just one example of how sometimes percentages are used in a somewhat misleading way. Now we're going to talk about things in a much more formal nature. So let's just kind of get into it. And you're going to start noticing some trends. We'll be talking about absolute changes, relative changes, absolute differences, relative differences. They're all essentially the same thing, just kind of looking at things in a somewhat different way. Let's start with absolute changes. So absolute changes, it says here, describes actual increases or decreases from some starting point or reference point. It's really very simple. So our formula would look something like this. An absolute change is just simply that new value minus some reference value that we're comparing it to. This, of course, will make more sense once we look at an actual example, like this one right here. The world population in 1950 was only 2.6 billion for the entire world. But by the year 2000, it reached 6 billion. So if we wanted to compute the absolute change in world population from 1950 to 2000, we would simply use this very simple formula. We're going to look at the new value. In this case, that would be the population in the year 2000, and then subtract the reference value. The reference value is where we began in the year 1950. So it's going to look something like this. 6 billion minus 2.6 billion. And again, just to make sure, let's use our calculator. So we'd have 6 essentially minus 2.6. Of course, we're dealing with billions, which would equal 3.4. So there's nothing complicated about computing these absolute values that we're going to be discussing today. And in this case, we're just looking at an absolute level of change. Where it gets just a little bit more complicated, and this, by the way, would be our interpretation, world population increased by 3.4 billion people from 1950 to 2000. And before I go on, let me just point out something important. By using our reference value over here in our equation, by taking the new value and then subtracting the reference value, we will have a positive number when there was an increase in our measurement. We will have a negative number when there's a decrease in our measurement. So it is important to do it in this type of order. All right, so as I was mentioning, the absolute change scores are very straightforward. Things get just a little bit more complicated when we start talking about the relative change scores. And this is where, of course, percentages start to come into play. So relative change is a ratio that compares that absolute change that we just computed to the reference point. So how big was that absolute change? How big was that change in the population from 1950 to the year 2000 relative to that reference point in the year 2000? And then we're going to compute this fraction. And because people understand percentages typically easier than fractions or decimal places, we're going to multiply 100 to make it a percentage. So this is how it would look here. Just to remind you of the information, in 1950 we had 2.6 billion people. By 2000, 6 billion people. So in this particular situation, we want to find that absolute change score. And remember, that was 6 billion minus 2.6 billion. And then we're going to simply divide by that reference value, the number of people who we had in our world in the year 1950. And then multiply that by 100. So again, we'll look at our calculator. We had 6 billion minus 2.6 billion. So we were left with 3.4 billion. And then I'm going to divide that by that reference point. So divided by 2.6 billion. Would give us 1.307. All right, so it's essentially telling us that this absolute change was 1.3 times that of the original starting point in 1950. Well, it's just simply easier when we convert that to a percentage. So let's just multiply by 100. So right here, I'm now going to hit my multiply key and multiply by 100. And that equals 130.77, let's say. So 130.77%. So the relative change in our population was 130.77%. We're going to round it up to like 131%. So one way we might say that is world population increased by 131% from 1950 to the year 2000. All right, so it's, relatively straightforward. An increase of 131%. All right. Let's go through another example. So let's compute absolute and relative change based on this information. The number of daily newspapers in the USA is now 1,456. Back in 1900, there were 2,226 daily newspapers. So clearly now we see there's been a decrease, particularly as information has moved online. So let's quickly compute that absolute change. Now, of course, the absolute change is simply going to be the difference between how many newspapers there are now compared to that reference point, how many there were. So as I was mentioning before, as long as we structure the equation so that we're taking our new value and then subtracting our reference point, our final answer will be negative when there's been a decrease and positive when there's been an increase. And again, just using our calculator to check our work. In this case, we would have 1,456, oh, that's a mistake, 1,456 minus 2,226, and that equals negative 770. So there are 770 fewer newspapers compared to the year 1900. Well, now let's compute that relative change. So of course, in order to compute relative change, we first have to compute the absolute change to figure out how much the difference was. And then we're going to look at that difference relative to the starting point in the year 1900. So that value is 2,226. So we find that difference, negative 770, divide by 2226, and multiply by 100%. Let's use our calculator. So we have already in the calculator, negative 770. I'm going to divide by 2,226, and that equals negative 0.3459. I'm going to multiply it by 100 so that we're not dealing with the decimal places anymore. So multiply by 100. And there we have essentially 34.59%, or about 35% or so. So, talking about a decrease of nearly 35%. So how would we sum that up? There are 770 fewer newspapers. That's our absolute change, which is nearly a 35% decrease since the year 1900. All right, so there we have an example of absolute and relative change. Now, what we're going to do next is very similar. Again, if you pay attention to the similarities, you'll notice these trends. We're just going to use slightly different terminology and look at slightly different examples. But now we're going to compute absolute and relative differences instead of changes. And just like it says here, theoretically and mathematically, absolute and relative differences, like we're going to compute now, are just like absolute and relative changes that we computed before, except now we're comparing different groups. So previously we were comparing the same measurement, like the number of newspapers, from like time 1 to time 2. Now we're comparing different groups. So we're looking at differences between groups. It's not like they have changed. We're looking at differences between groups. And that's simply the only reason why now we're changing the name, and it's a new measurement. The formulas are essentially exactly the same. When we looked at relative change, we first computed the absolute change, and then we divided by a reference value, multiplied by 100. Now that we're looking at difference scores, we will compute that absolute difference, and then divide again by a reference value, multiply by 100, so we're dealing with percentages. Let's go ahead and try a quick example on our next page. This one's kind of interesting because my wife owns a driver training school, and she's often dealing with 16-year-olds who are driving. And as you probably know, they get into more accidents than really anyone. Older drivers are often criticized as being poor drivers as well, but as you can see here, the numbers hardly match up. So let's go ahead and compute absolute and relative differences based on these numbers. 80-year-old drivers get into about 5 crashes per million miles driven. That's PMM in this case, per million miles driven. While 16-year-olds get into about 31 crashes per million miles driven. That's a pretty darn big difference. So compare, now we're doing comparisons to find these differences, the younger drivers to the older drivers. So let's first look at those absolute differences. So again, we're going to compare the younger drivers to the older drivers. So those older drivers are going to be our reference point. So we're going to take that 31 and we're going to subtract it from our reference point, 5, for the 80-year-old drivers. So here we have 31 minus 5 crashes per million, which will give us a difference, an absolute difference of 26 crashes per million miles driven. All right, well, we often like to express that as a percentage. So if we're going to compute the relative difference, we now want to look at how big is that absolute difference relative to, remember, that baseline measurement, relative to this reference value. So we're simply going to look at, in this case, 26 divided by 5, and then multiply by 100. So let's go back to our calculator. Here we've got 26. We're going to divide it by 5. That gives us 5.2. And then we will multiply by 100 to convert that to a percentage. So 520, or 520%. That's a pretty big difference. So how would we summarize both of these measurements that we just made here? Maybe something like this. Young drivers get into 26 more crashes per million miles. That would be the absolute difference, which is a rate that is 520% more than that of older drivers. That's a pretty big difference. All right, let's go ahead and look at another distinction. Here's where things start getting almost like we're splitting hairs. But because the results that we talk about are different, it's important that we understand what's actually being computed. And this is the difference of kind of how we word our response. The analyses that we use are associated with different types of language. So here we're talking about a difference of a word of instead of more than or less than. You'll get what I mean in just a second. So again, let's look at that data. 80-year-old drivers get into about 5 crashes per million miles driven, while 16-year-olds are getting to about 31 crashes. So our first way of looking at it was that young drivers get into 26 more crashes per million miles, which is a rate 520% more than that of the older drivers. All right, well, we can look at this another way as kind of a ratio of those crash rates. And if we look at it that way, we see for the 16-year-olds, the crash rate is 31 crashes per million miles. And we look at that over our reference point, which is the crash rate for the older drivers, 5. And now when we work that out real quickly, we have 31 divided by 5 equals 6.2. If we want to convert that to a percentage, we're going to multiply by 100, and we find that that equals 620%. Now you can see that answer is essentially 100% more than the answer that we got previously, more than the answer that we got right here. And all that simply means is now we describe our results in a slightly different way. This is telling us that young drivers get into 26 more crashes per million miles driven, which is 620% of the rate for older drivers. It's just a small distinction in the way that we talk about the numbers. And the reason why this makes sense is the older drivers are getting into 5 crashes per million miles driven. If we were to take, let's go back to our calculator here, that value of 5 and then multiply that by 620%, which is multiplying it by 6.2. So multiplied by 6.2, we would find the rate of crashes for those older drivers, 31 crashes per million miles driven. So it's a very subtle difference in terms of how we're actually talking about the data, but you can see that there are differences in the actual numbers then, those percentages. And this is one reason why people find it confusing, and it's one reason why people sometimes use this information to their benefit, because they know they can more easily confuse people. Let's go through another example. Earlier we found that the world population in 2000 was about 6 billion people, and we found that that was 131% more than the world population in 1950. So how would we express that type of change in terms of an of statement? Well, you might recall, and let's just go back for a second, the only thing we had to do differently here was essentially add 100%. So in this particular situation, all we should need to do to the answer that we found previously is add 100%. So if we found that the population in the year 2000 was 131% more than the world population in 1950, then by adding 100 to that 131%, we'd find 231%, and that would mean now that the population in the year 2000 was 231% of the population in 1950. And again, like I was explaining before, this simply means that the 2000 population was 2.31 times that of the population in 1950. And we can verify that. Unfortunately, I think I just closed my calculator. Let me open it up again real quickly. So let's just verify that real quickly. We had the population in 1950 was 2.6 billion. And now we can multiply that by 2.31. And again, we find the new population in the year 2000 being about 6 billion. So that kind of summarizes what I did right there. All right, so again, these are subtle differences in the way that our results are worded, but we want to understand them so that we can understand results that are presented to us and so that we can present results in a fair way. All right, now that was quite a lot to take in, so let's just kind of catch our breath for a second. Let me give you a little bit of information. I know that these analyses can be kind of confusing. I mean, they confuse me too, like when I'm working on them. You really need to think them over and practice. But like I'm mentioning over here, if you pay attention to the trends, you'll see everything that we just computed was essentially the same. We just used some different words. We computed the absolute differences between values and then the relative differences between values. So hang in there and just go over some examples that are in the textbook, and then we'll go over some examples together when we're in class. Now, here's another interesting point. We do see these same types of confusing issues daily. Here's a quick example. Let's say that one store advertises 1/3 off of everything. I mean, that sounds like a great sale. And another store advertises a sale price that is 1/3 of the original price. And again, that's a very subtle distinction in wording, right? So my question to you is, which store is having a bigger sale? And just to keep things easy, let's just assume that all products in both stores cost $9 originally. It'll just make it easy to kind of do the numbers. Well, if 1/3 is going to be taken off everything, 1/3 of $9 would be $3. So we'd be taking off $3 and everything would cost $6 at the first store. But now with this very subtle wording change, if sale prices are just 1/3 of the original price, now we're talking about the sale price being 1/3 of $9. And 1/3 of $9 is $3. So in the second store, everything just costs $3. So very similar wording, very slight change, but pretty profound differences overall. All right, let's discuss one more thing and then be done with this. This is another kind of oddity regarding percentages, and this particular example involves health statistics, so most of you will probably find this interesting. Comes from a very well-known study over the past 10 years or so, and this is a study on hormone replacement therapy. And hormone replacement therapy women often take when they're experiencing symptoms of menopause, and when they replace hormones that their bodies are no longer manufacturing in sufficient amounts, they then no longer have some symptoms like hot flashes and things like that. So it's a pretty important issue. It affects a lot of women. Now, it's always been understood, or at least believed, that based on the evidence, that hormone replacement therapy can increase chances of some cancers. But it was always thought originally that hormone replacement therapy actually cut a woman's risk of some heart diseases. But this study, which was a great study, actually found the opposite. And they found that women taking hormone replacement therapy, of those women, 1.94% developed what they were terming coronary heart disease. And of those taking a placebo, 1.51% developed coronary heart disease. And this was a wonderful study, a true experiment done on many thousands of women. So compare those with hormone replacement therapy to those taking the placebo. So first, just let's look at that absolute difference. And the absolute difference is very straightforward. Again, we're going to look at the women taking the hormone replacement therapy, and we're going to compare that to some baseline measurement, some reference point, which would be the people in the control group taking the placebo. So it's a difference of 0.43% in terms of those developing heart disease. That sounds very minuscule, doesn't it? It sounds like, why would this study get so much press? Well, it did get a ton of press. I mean, it was on every single news program. It was in every single newspaper. And this is why. Remember, the results can be expressed a variety of different ways. And these percentages in health statistics are typically referred to as the risks, the risk rate. So 1.94% developed heart disease. The risk is essentially 1.94%. Well, when we talk about the differences between the groups, we usually discuss those differences as a relative effect. So let's compute now the relative difference. Remember, first we had to compute the absolute difference, and then we're going to look at that absolute difference relative to some reference point, some baseline measure. And in this case, that would be that control condition that received the placebo. So we're going to set it up like we normally do. We take that absolute difference that we just computed above. I'm going to divide by that baseline value, multiply by 100 so that we convert it to a percentage. We'll pull out the calculator. We'll take 0.43. We will divide that by 1.51, and we get 0.2847. Let's multiply that by 100, and we get 28.48%. So 28.48%. Now that's a very different number than this, right? And it's telling a pretty different story. So look at this summary that we have right here, and you can see why this captured headlines. So although the absolute increase in risk was less than 1%, the relative increase in risk was over 28%. So the headline read, women taking hormone replacement therapy increased their risk by 28% for heart disease. That scared a lot of women, and they stopped taking their hormone replacement therapy, often without even consulting their doctors. People sometimes really don't understand the statistics. I want you to be able to actually look at those numbers and make sense of it. So if you're in this situation, or if you're consulting with patients or people in your family or friends, whatever it might be, you can help explain those results. Absolute difference in this case really is much more straightforward to understand and much less scary. Well, I know that was a lot to take in. I'm sorry that it was kind of painful. A lot of the other chapters get much more interesting, so let's just kind of suck it up. That was the key content from section 2.3, and for now, that is all.